It's finally time for another episode of our real-life Power Armor series. So far, we've built most of the upper body, demonstrating it curling 300 pounds or about 140 kilos, and made an epic heads-up display with augmented reality, meaning even if you lose power, you're still going to be able to see. Speaking about losing power, that's what this episode is all about. How are we going to power it? And is there a chance that Bogdan's going to get spring-locked in the suit? As you saw on the TV show, if you lose power, you're kind of screwed. Should we make ours better than that, or stay true to the source material? You guys have been asking some great questions in the comments and giving us some awesome suggestions too. So in this episode, we're going to dive deep on why we've made some of these engineering decisions that we have, like using pneumatics over hydraulics or motors. There's a lot to do, and we've been working around the clock on this project. We're super excited about how excited you guys are about this project, so we're going to do our best to create more videos to keep you guys informed and up to date on our progress. Now, I think it's time I start working on the fusion core.
Now a lot of you were wondering why we chose pneumatics for this project. Well, you see, we could have gone with electronics or hydraulic actuators, but there's a lot of factors to consider.
Bogdan, can you just simplify this a bit, please?
Alright, let me show you. So our three options are hydraulic, electric, and pneumatic actuators. Basically, hydraulics use a liquid, like water or oil, to transfer mechanical energy, and they're extremely strong. Things like our industrial excavator, skid steers, and our giant mechs rely on hydraulics for massive lifting power. Like the power loader that weighs 11,000 pounds and can pick up 7,000 pounds, or Megahex that weighs 8,000 pounds and can carry its own weight. The big drawback with hydraulics is that they're bulky and heavy. And although smaller hydraulic cylinders do exist, like the ones we used on Iron Spider, all the hoses and fittings are still really cumbersome. Hydraulics are also slow. For example, the lift for our power armor uses hydraulics. Yeah, it's pretty underwhelming. And since there's no easy way to store hydraulic power, you need a big, powerful engine in order to run it, like this Caterpillar engine that our power loader uses. So I think hydraulics are best left for large industrial mechs. On the other hand, are electric actuators. Things like linear actuators, motors, and servos fall into this category. They usually use some kind of gearing to transfer energy and are very fast and precise. Electric actuators are perfect for things like robot dogs, humanoid robots, autonomous lawnmowers, or our Sisu camera robot. And it's fast and precise because it uses electric actuators. These motors, however, are still quite large, and you need a whole electronics cabinet to operate them. And this thing only has a 22-pound payload. Pretty strong, but not superhuman. The other downside is that motor power is distributed. Imagine that I have one of these motors on each arm. One for my left arm, one for my right. But I only want to curl something with one hand. Well, this arm is going to be doing all the work, and this one is kind of just dead weight. In a hydraulics or pneumatic system, both of these motors could be hooked up to one pump, which means if I wanted to curl something with one arm, all power could be diverted to a single joint. It's literally like in sci-fi movies, when they say, divert power to life support systems, or full power to thrusters. With a hydraulics or pneumatic system, you could actually do that. So overall, while electric actuators are getting better by the year, they're still not at the level of superhuman strength. So we're going to keep them for smaller robots. And finally, pneumatics, my favorite option. Pneumatics use compressed air to transfer energy. And they're often used in conveyor sorting, roofing nailers, and truck suspension. Now while pneumatics are quite a bit weaker than hydraulics, for reference, this cylinder can operate 3,000 psi. This one, 150, about 20 times less. They will still give us superhuman strength. And they're lightweight, fast, and easily back drivable. That allows us to mount them on the arms and still move freely, allowing us to do fine movements by hand with no power, unlike hydraulics. And that's why we decided to use pneumatics for our power armor. And so far, it feels like the right choice. Not to mention that in the Fallout universe, the suit goes oh yeah, that sounds like pneumatics. Alright, so we're gonna do some compressor tests. First things first, before we test the new compressor, we need a reference point. So, we've got the compressor that's been in the original Call of Duty exoskeleton in here, and we're actually overvolting it. It's supposed to run on 12 volts, we're running at 24. That's almost twice as much power. Let's see how well this one holds up. I've got the pressure gauge over here. I'm gonna pump this thing up to, let's just go all the way. 150 psi and time how long that takes. It took about a minute to get to 100 psi, but the suit runs at 200. Now this compressor can't do 200, so we'll use 150 as a reference point. That is 1 minute and 39 seconds to get us to 150 psi. So let's empty the system, hook up our new compressor, and give that a test. See if this one does any better. 3, 2, 1. We are at 217 and we've reached 150 psi. Now, that might not sound impressive, but the cool thing, this compressor is only at 45 degrees Celsius, which means we can push it harder. Try number 3. So this is going to be our bigger compressor, running at 24 volts. 3, 2, 1. All right, minute and 39. About 57 seconds for the first one, a minute 39 for the second one. All right, not as much of a performance boost as I was hoping for. Now the nice thing is this compressor can go to 200 psi, which means you can get more pressure at the end, but the fill rate is still a little bit low. Let's see what we can do. This motor right here is only a 550 watt motor. That's not super energy dense because this is a brushed motor. This right here is a brushless motor, and this can put out over 2 kilowatts, which is about 4 times as much as this giant motor here. So theoretically, we'll remove this big brushed motor, make a mount for this brushless motor, and the whole system will be smaller, lighter, and almost 4 times more powerful. Here's the new pump, and we've got the O drive and the new motor attached to it, which means that this entire pump is not only way smaller and way lighter, but also more powerful than the old brushed DC motor. Let's give it a test. For this upgrade, we're using a high-power brushless motor with an O drive Pro controller to give us maximum power and high precision control. Okay, I'll be right back. You want to hook it up and get the software running?
I think he underestimates how long it's going to take me to do it. I'm done.
Nice.
That was it. That was my job.
Got a fresh set of batteries. We've tuned the motor properly now. It's all hooked up. Let's see how fast we can fill that tank. All right, so we got up to 100 psi in 48 seconds, and then another 42 seconds later, we are at 150 psi, which gives us about a 15% improvement. That's quite good considering that this pump is way smaller, lighter, and has a 100% duty cycle, which means it can pump that flow continuously. So I think we're ready to mount this onto our power pack. Let's take a second to base fiction in reality and talk about power sources. So far, we've been powering our suit with lithium polymer batteries. And while battery technology has gotten really good over the years, it's still nowhere close to fictional technology. Let me explain. This battery is 350 watt hours and can run the suit for a little over 7 minutes. Which means if we wanted to run the suit for, let's say, an hour, we would need 8 of these lithium polymer batteries. Now, while I could theoretically fit this onto my bag, it'd be pretty impractical, not considering the fact that they would take over 2 hours to charge from a regular wall outlet. For comparison, if we were to just use gasoline, we would only need a 300 milliliter pop can worth of gasoline to equal the same amount of energy, about an hour of runtime, as these 8 lithium polymer batteries. That's a huge difference. Now, we don't have nuclear fusion yet, but what we do have is nuclear fission. If this suit were to run on nuclear fission, we would only need a grains of sand worth of uranium fuel to actually run the suit for over an hour. And if fusion did exist, that would go down to a single speck of dust. Pretty crazy. Which means if this nuclear fusion core actually had a cryogenic storage container that could hold about 300 milliliters of deuterium tritium nuclear fusion fuel, such as this one, that would be able to run the suit at full power continuously for over 100 years. Makes sense why, fiction likes nuclear fusion so much. Unfortunately, nuclear power is not available to me, so I'll have to stick with the next best thing, which is gasoline. Now this little generator is able to run our suit continuously for over 4 hours on just 2 liters of gasoline, and it's much smaller and lighter than the lithium-ion batteries. Additionally, a gas tank is easy to refill, which means you can get a full day's worth of work, about 8 hours, on just a single refill. Now you might be wondering, why bother with all this energy storage? The system runs pneumatics, so why not just store enough air on the back to run the system for an hour, let's say? Well, the problem is I need 2 of these high-pressure air tanks on my back to run the suit for an hour. So I think I'll stick with gas, which means we need to figure out how to mount this on my back.
All right, while Bogdan works on that, I'm going to tell you a bit of a personal story. I don't usually talk about this publicly, but I'm actually a dad now. I've got 2 young kids, and I've noticed an unexpected consequence of becoming a father. and that's that I'm turning into my dad and many other dads out there, and I've become obsessed with the thermostat. I've got sensors in every single room in my house. I've got zone control, and I spent all too much time worrying about the comfort of my family. That's why I'm genuinely excited about this video's sponsor, MrCool, and they sent us 2 heat pumps, so let me show you that. So this is a 4-ton DIY mini split, and the great thing about this is that you can install it completely by yourself. It's got quick connect fittings, so instead of hiring a professional with specialized tools and thousands of dollars, you just plug it in. We did this completely ourselves. It heats, it cools, works great. This is the other unit, it's the Versa Pro, and it's been an absolute lifesaver for James. Let me show you why. His house is about 100 years old and has an oil boiler, and these things are expensive. They cost about $1,000 a month to run in a Canadian winter. Not only that, but he had a radiator burst last week. So we replaced his existing air conditioner with the MrCool heat pump, and it was minus 22 last night, which is not a good time to be without heat. I'm a big fan of heat pumps, and MrCool makes some of the best on the market. So if you want to keep your family comfortable, check out the link in the description.
All right, now that the design is done and we got the backplate cut, it's time to populate this with all the components. And I'm gonna get Sarah and Jacob to help me out. You guys supposed to follow me. Okay, so the first thing is to take all the parts we're gonna need off the old power pack and start mounting them onto the new one.
Decapitating the power armor.
Decapitating the power armor. Perfect, and there we go. Full helmet. Our spinal cord is out. And that makes it so much easier to work on. Look at all this breathing room. As we get more and more parts off, the speed of taking things apart will get faster because you have more access to things and it's easier to reach parts. But the new system, the way it's laid out, should be a lot easier for maintenance. It should be a lot easier to get access to all the components. There should be a lot more space for wiring and zip ties. So I'm pretty excited for it. Because right now working on this has kind of been a nightmare. Every time you have to change a fitting, it's just like, I can't get access to anything. Everything's just zip tied and underneath other stuff and underneath this back panel and cover. And all right, now that we have access to the electronics, I can start unhooking these up. But unfortunately, Owen can't really see them because neither can I. Remember on the first day you were worried you weren't gonna get to do any mechanical stuff?
Oh yeah, this is like a bit.
And now you're like, ah, I should have just stuck the software. And there is the old pump. All right. Now that we have our new compressor and we figured out how we're gonna power the whole thing, we need to figure out how we're gonna fit everything on my back. Now the old power pack looks nothing like the Fallout power armor, and it's pretty poorly optimized in terms of spacing. So I've gone ahead and redesigned everything from scratch. And this is Power Pack V2.0. The whole thing starts with a laser cut piece of perforated aluminum, which is gonna have all the mounting holes we need to mount things to it. Then we can mount the DC power supplies, the valve block, and the engine control unit. Since the whole system is now running on 48 volts because of the generator, we need the DC power supplies to ensure that the rest of the system can get 12 and 24 volts. Now for the engine and generator that I showed earlier, that's gonna get mounted right in the middle. Since it makes so much vibration, instead of using standoffs like we did for all the other parts, we're gonna be using grommets to mount it, which are basically little rubber pieces that you put inside of a hole to reduce vibrations. There we go, there's our generator, fully on the back. We're gonna mount the pump off to the side and at an angle to actually replicate the way that the tanks are mounted in the Fallout power armor. The fuel tank is gonna get mounted at the same angle as the compressor across from it to make it mirrored, and it's gonna provide all the fuel we need to run the engine. We're gonna use the exact same air tank as before and mount it around hip height, which is pretty much the same as the bolt pattern we have on the Fallout power armor. Man, this thing is really starting to come together. Excited to wear it. Have all the power on my back. Oh my goodness, it is heavy. And then to distribute all the air, we're gonna have the manifolds mounted right above it with 90-degree elbows.
Can do a Bogdan.
And since we have some extra space behind the tank, that's where the batteries are gonna go. There we go, there's our 2 batteries. If you remember from the last episode, the original power pack just had Ryan's Jetson simply zip tied to the air tank. Military grade power armor, held together with zip ties. Which is not gonna cut it for the real power armor. So we made a nice case for it and mounted it to the top left of our power pack, right near the helmet. In order to control the arm cylinder extension and retraction, I've added 2 more solenoids on either side of the generator. And the valves are pretty low profile, so they should be able to mount right underneath our exhaust. We also wanted to be able to power external devices, like a laptop charger or a filming light. So we added an AC inverter in the top right corner so we can plug in anything that has a regular wall outlet. And one of the things that I'm most excited for is upgrading our industrial controller, the Coonbus Revolution Pi. We just recently got a new one with some relay modules, and this thing is going to control the whole suit and really bring it to life. And that's going to get mounted at the very bottom. And after days of plumbing, wiring, software changes, and finishing touches, I'm finally ready to show you one final addition. And as always, if you'd like to see the updated schematic diagram, make sure to check out the maker.io link in the description below. Alright, so the power pack is all filled up, the code is all done, and we're ready to fire it up. But for this test, I want to test out one more feature. In the past, we've been using these controllers to run the suit, but I don't really want to have half a dozen buttons on each hand. I want to make it a lot more intuitive, and I've got a plan for that. Inside of our arm, we currently have the pressure cuffs that keep my arm in place. There is one on top and one on the bottom. So what I've done is I've actually put together this little assembly. And what these allow me to do is actually activate the pneumatics and move the hand up and down by just moving my arm, instead of having to press a bunch of little buttons. All right, shall we power it up? Nice. Get our hand in there. So system's open. Here, get my hand in there. System closed. Cool. We're going to latch this. So these are on. We're going to inflate. Awesome, awesome. I can feel that inflating around my arm. Well, the first mode of the suit is completely unpowered. The power pack is doing nothing, and the air is being vented. This gives me really good precision control, but no extra power, and the suit is doing absolutely nothing. Now, if I turn that off, the next mode is going to be our pressure cuff control. So I can use the pressure cuff, and now the system is going to give me about 150 pounds of lifting force. Now, if I push my hand down, this is sweet. No controls, no buttons, no levers, no switches, just my natural movement of, hey, I want to move my arm up, arm comes up. I want to move my arm down, arm goes down. Jay, check this out. Up, down.
I mean, that's a true exoskeleton, something that actually detects your movements, augments your strength.
So now if I'm just here and try to resist my arm, I have to go like this. Okay, just pulling my body forward. But the cool thing is, right now the suit is pretty stiff. But the cool thing with pneumatics is I flip that vent switch, free moving, no issues. I turn that back off.
Means he can't get spring locked. Arm go in.
Yep.
Yep.
So you're latched, inflate.
It's like I'm having my blood pressure taken. So now if
So move your wrist up like this.
That's so intuitive.
So I can tune this in the software to make it more or less sensitive.
Our first exoskeleton that actually augments human movement.
Obviously we're going to fine tune this and maybe run some kind of PID algorithm to actually re-zero the system as it fills and inflates. Because right now, if you actually just hold that there, because of the weight of the suit, just hold the weight of the suit.
Yeah.
You can actually see that this one is already much higher than that value. So what I could do is I can add some custom software to basically inflate, have a zero, like a button that zeros your suit, and that says, okay, this is your natural, force, and then from there measure the differences. Because right now it's just trying to see if one is 200 psi higher than the other. And then yeah, if you want to have free movement, you just flip this one switch.
Judging by how well these air pressure cuffs work,
Right?
I think the legs will actually be able to walk.
With good proper tuning, I think this can work. Obviously, this is right now zip tied in place and has holes that are pinching, but
Yeah, because if it doesn't take, once the weight's on your right leg,
that's the thing.
you can initiate the leg to lift up, and then it'll actually be holding your leg up, and then all you have to do is swing your hip.
Exactly.
And swinging your hip doesn't take much effort compared to holding the weight.
And the way that
the weight's in the other leg.
The way that we set up these cylinders is we have bidirectional control of the pneumatics plus a vent. So we're able to have it either just be stiff with your manual control, we can have it be fully loose where you take the full weight of the suit, or we can have nice and slow control, or we can have full speed control if you want to really give it all pressure. All right.
Awesome.
So
That's right.
obviously all that testing, our compressor is going to be getting low, so we'll be able to fire up the compressor. So what you'll be able to hear is as the compressor pumps up, it's going to get to about 100 psi, you'll hear it actually start slowing down because of energy. You can see the batteries are a little low. We'll have to run the generator in a second. So now if you move the suit, it's keeping pressure up. So as James is using the suit, right now the compressor is running to keep pressure in the tank off of the batteries. But as soon as the batteries get low, here, I'm gonna dump some air.
This suit is gonna be so menacing. Just imagine walking in the parking lot and then.
But yeah, I mean, you're at 46 volts right now, so you should be able to keep going. The compressor will fire back up.
So this might not seem like a ton of progress, but there is so much systems design in here that you've done a fantastic job on.
Yeah, it took weeks to cram everything onto a single power pack.
You basically made a hybrid power pack. Like
Yeah.
a Toyota Prius.
Pretty much. You might be wondering, what's next for the Fallout Power Armor series? Well, while James works on the Fusion Core, I have to get this thing mounted, make sure it can open and close, and start doing the design of the legs. Which means I'm going to need to do a lot more research by playing Fallout 76. And while I'm at it, I might as well get ready for the new upcoming update that allows you to become a fully customizable ghoul, complete with radiation immunity, 32 exclusive perks, and all new mechanics like glow and the feral meter.
Hope you guys are enjoying this series. We're gonna try and get as many episodes out as soon as possible for you guys, so make sure you subscribe, leave us a comment below, and like the video. It's your support that helps make projects like this possible.